So now in this part, we want to know something about the rectangular coordinates. We know that we want to express, we want to represent a point graphically. So we use the rectangular coordinate system. This is also called the Cartesian coordinate system. So what is the rectangular coordinate system or the Cartesian coordinate system? It is composed with two lines. One is a horizontal line, which represents the x-axis. Another one is the vertical line. This is called the y-axis. So any point in the plane can be written as a pair of numbers. One is called x, the other one is called y. And here is this x is called the x-coordinate. If we draw a vertical line to the x-coordinate, that is this number, x. Okay, if we draw a horizontal line and vertical to the y-axis, which is this one, is y. So this point is xy point. If x is 1 and x is 5 and y equals 1, then this is a phi 1 point. And the intersection here of these two vertical lines, this is called the origin. Origin has the coordinate is a point we denoted by O. And it has coordinate 0 and 0. This is the origin. And we also notice that these two lines, two vertical, horizontal line and the x-axis and the y-axis, divide our plane, the whole plane, into 4 quadrants. This is called the first quadrant. We label these 4 quadrants counterclockwise. This is the first quadrant. This is called the second quadrant. And this is called the third quadrant. And this is the fourth quadrant. Okay. So this is called the coordinate system. So for example, if we want to plot a point which is -1, 4, what we should do? We should have xy coordinate. And here is 0, 0, 0, 0, 0, right? This is the origin. So here is 1, 2, 3, 4. And here is -1, -2, -3. Here's 1, 2, 3, 4. And here's -1, -2, -3. So this is the x-axis, and this is the y-axis. So -1, 4, the first coordinate, is called the x-coordinate. So you need to locate where is -1. So since here is 0, so -1 would be here, right? And the second coordinate is called y-coordinate. So where y-coordinate equals 4, 4 is here, right? This is the 4. So this point, which is -1 and 4, right? This is -1 and 4. So you can use this way to locate our -1, 4 point. So now, since we can represent any point in the plane by a xy pair, so now we want to determine the distance between 2 points. Okay. So if you have, so the idea is the following. If you have this point and this point, right? The distance between 2 points is actually this side C, right? We can always draw a right triangle if this is A and this is B. What is the side C? We can use the Pythagorean theorem. Says, okay, this is A squared plus B squared equals C squared, right? Then C, since C is a length, so it must be positive. So it would be the square root A squared plus B squared. Of course, it's negative. If you solve the equation, you should have the negatives plus or minus sign, but since this one has some geometry meaning, so this C must be a non-negative number, so it must take the positive here. Okay, so we use this idea. Let's look at the 2 points in our xy coordinate. So we have this point, which is x1, y1 point, and this is x2, y2 point, okay? And this is the x1, and here is x2, and here, oh sorry, here's y1. This is the x2, and here is what? y2. So we want to find the distance between these 2 points. So we actually notice that we actually have a right triangle, which is given by this one. Okay. So the length for this part is x2 minus x1, right? Of course, if you're not sure x2 minus x, which one is bigger, you just use the absolute value. But it doesn't matter. At last, we will square it. We don't care about its positive or negative. And this one is what? Is the y1 minus y2, right? So this is our D. This is the distance between these 2 points. So we can use the Pythagorean theorem. Okay, our D is equal to the square root, right? Like our C here. D is equal to the square root of x2 minus x1 square plus y1 minus y2 square. But for the beauty of the formula, because this is here is x2 first, here is x1 2 first, then 1 we can write as a y2 minus y1. But it doesn't matter, right? Because you squared, it's always positive. So this is the formula for the distance between 2 points. Okay, so now let's look at one example. If you have, we want to show that 2, -1, 5, 5, 6, -3. These are 3 vertices of a right triangle. Right triangle. Okay. So if you have vertices of 3 points, okay, right? 3 points. So this is, for example, this is 5, 5. This is 2, negative 1. And this is 6, negative 3. So we form a triangle, right? If we want to show that this is a right triangle, we need to show that the sides, the 3 sides, follow the Pythagorean theorem, right? So now let's look at if this is the D1 side, and this is the D2 side, and this is the D3 side. Let's calculate the distance between 2 points. D1 is the distance between these 2 points, right? So it's the square root 5 minus 2 x minus x squared plus y minus y, 5 minus negative 1. So this one would be the square root. If you calculate, this would be square root 45. Of course, you can simplify, but we don't care so far. Of course, this can be written as 3 square root 5, right? If you simplify it. And the D2 is the distance between these 2 points, right? So we still have the square root x minus x squared, right? This is 6 minus 2 squared plus negative 3 minus negative 1 squared. So this one is, if you do the calculation, it would be square root 20. If you simplify, it would be 2 square root of 5. D3, which is the distance between these 2 points, we use the distance formula. So this one would be 5 minus 6 squared plus 5 minus negative 3 squared, right? So you have, this one is actually 65. Okay, so now we need to show that, let's look at D1 square. D1 square is 45, right? Which is square this one. D2 square, which is 20. And the D3 square, which is 65. So we note that this D1 square plus D2 square equals D3 square. That is the Pythagorean theorem. So that this one is a right triangle. It is a right triangle. So this is just the application for the distance formula. Now let's look at the midpoint formula. So the midpoint we denoted by M. M represents the middle point. The middle point is the point exactly halfway between 2 points. If you have these 2 points, this is the P, which is x1, y1, and this is the Q, which is x2, y2. This is the connection between these 2 points, and this one would be the middle point, M. So what is M? Okay, the middle point is actually, M can be written as the average of the x-coordinate of these 2 points. So x plus x1 plus x2 divided by 2. And the y-coordinate is the average of the y-coordinates of P and Q points. So y1 plus y2 over 2. Okay, so now let's look at a very simple example. We want to find a midpoint of the line segment between -2, 8 and 4, -10. So the midpoint is, so if this is x1, this is y1, this is x2, and this is y2, right? The midpoint is the average of the x coordinate, which is -2 plus 4 divided by 2. And the y coordinate is the average of the y coordinate, 8 plus -10 divided by 2. So this would be 1 and then -1. Okay. Translating. So next we want to look about how to translate the points in the plane. Translating. Okay, we use some examples to help you to understand how to translate a point in the plane. So if you have a point, which is this point x and a y point, we want to shift this point two units to the right and 5 units up. Okay, so if this is the x, 2 units, 1, 2, right, would be here, and 5 units up, 1, 2, 3, 4, 5, so it would be here, right? So what's this point? This would be x plus 2 and y plus 5. So our point would be x plus 2 and y plus. So for example, if you have a point which is 2, 3 point, we want to 2 to the 2 units to the left. We want to shift this point 2 units to the left and 1 unit down. The 2 units to the left, so you should subtract 2 on the x coordinate. So this 2, 3 point becomes what? We subtract 2 on the left, on the x coordinate, and the 1 unit down. Down means the y coordinate will be subtracted by 1. So which is 0, 2 points. Right. We shift to the 1, 2, right? Then down 1 unit down. So which is this one, right? 1, 2, then down 1 unit. So 0, 2. Let's look at another example. If we have a triangle, this triangle, this is the vertices. We have three vertices: -1, 1, -2, -4, -1, -1, and 2, and then -3. We want to shift this triangle two units up and 3 units to the right. So if we shift a triangle, we didn't change the shape. So we actually are shifting the vertices. So you just needed to calculate the shifting point for the vertices, right? So 2 units up. That means we add 2 to each y coordinate. Okay, y coordinate. 3 units right. That means add 3 to each x coordinate. So our first point, first vertex, which is -1, 1, -1, -1, -1, -1. So it becomes what? -1 plus, with to the right, so plus 3, and up 2 units, so -1 plus 2. So this one would be 2 and 1. And -2, -4, it becomes -2 plus 3 and -4 plus 2. So this one would be 1 and -2. And this is the, another one is the 2, -3. So this is the 2 plus 3, -3 plus 2. Right, so this is 5, -1. Okay, so actually so it looks like this one. Right, it looks like this one. We shift from here to here, right, to here. Another example, we want to find all points having a y coordinate of -3, whose distance from the point P, which is 1, 2 point, is 13. Okay, let's draw a graph to help you to understand this problem. So this is the -3, the y coordinate -3. 1, 2, 3. So this is -3, right? All the points on this horizontal line have the y coordinate -3. And 1, 2 point, 1, 1, 2, So this point P, which is 1, 2 point. Okay, we want to find the points on this horizontal. In other words, we need to find the points under this horizontal dashed line such that the distance between the points and the point P is 13. Okay, so we may have this one, we may have this one, right? Okay, so here is, so every point, any point on this dashed line can be written as x and a -3, right? So we want to find these x values. So make the distance between 2 points equals 13. So the distance between 2 points is what? Is 13. How to calculate? It's equal to the square root x minus x, so x minus 1 square, plus y minus y, so -3 minus 2 square. So if we square on both sides, so it would be, if we solve this one, we need to square both sides, right? So this is x minus 1 square plus 25. Okay, so x minus 1 square can be written as is equal to what? 144. We subtract 25. Then we can use the property, right? Square root property. So x minus 1 equals plus or minus square root of 144, which is 12, plus or minus 12. So x minus 1 equals 12, or x minus 1 equals -12. For this one, x equals 13. For this one, x equals -11. So what you have 2 points. One point is 13 and a -3. And the other one is -11 and a -3. So from the graph, we know it has 2 points, right? So this is the -11, -3, and here is 13 and 3.